Welcome back. Today we tackle a topic that scares a lot of beginners but really shouldn't: IP addressing and subnetting. We'll keep it concrete. By the end you'll know how an IP address is built, what a subnet mask actually does, the difference between private and public addresses, and how to read that /24 notation you keep seeing. Let's start at the beginning. An IP version 4 address is a 32-bit number that identifies a device on a network. We write it as 4 octets separated by dots, like 192.168.1.10. Each octet is 8 bits, so it ranges from 0 to 255. And crucially, every address has two parts: a network portion, telling you which network, and a host portion, telling you which device. So how does a device know where the network part ends and the host part begins? The subnet mask. It's a second 32-bit number, like 255.255.255.0. Where the mask shows 255, those bits are the network. Where it shows 0, those are the host. The device uses this to decide whether a destination is on its own local network or must be sent off to the gateway. Writing full masks is clumsy, so we use CIDR notation, a slash followed by the number of network bits. 255.255.255.0 becomes /24, because the first 24 bits are network. That leaves 8 host bits, which is 256 addresses. But 2 are reserved, the network address and the broadcast address, so you get 254 usable hosts. Here's a key idea. There simply aren't enough public IP version 4 addresses for every device on Earth. So we reuse private ranges inside our local networks. The 3 private ranges are 10. The 172.16 block, and 192.168. Your router uses something called NAT to share a single public address among all your private devices. That's why every home router hands out 192.168 addresses. Now a vital troubleshooting clue. If a device asks for an address but no DHCP server answers, Windows gives itself an address in the 169.254 range. This is called APAPA. Seeing 169.254 is a red flag. It means the device could not get a real address. On the Helpdesk, that almost always points to a DHCP problem or a broken physical connection. Spot it instantly. Let's do a little maths, the easy kind. The number of host bits decides how many devices fit on a subnet. The formula is 2 to the power of the host bits, minus 2 for the network and broadcast addresses. A /24 has 8 host bits, so 2 to the 8th is 256, minus 2 is 254. A /25 has 7 host bits, giving 126 usable hosts. Simple. Let's bring it together. An address plus its mask reveals which network you're on. A private address plus NAT is how your whole house shares one internet connection. An APAPA address tells you something's broken. And CIDR notation lets you read a subnet size at a single glance. These 4 ideas cover the vast majority of addressing questions you'll meet on the job. Let's recap. An IP version 4 address is 32 bits in 4 octets. The subnet mask splits network from host. Private ranges and NAT let many devices share one public address. And APAPA signals failure. Your task: run ipconfig, record your address, mask, and gateway, convert the mask to CIDR notation, work out your network address, and count how many usable hosts your subnet supports. Then confirm your address is private. See you next time for DNS and DHCP.